Go ahead and get right into this, guys. So I put a review question because we've been gone for a week, almost a week. If we were absent today, we would have been gone for a whole week, right? Bless you squared, bless you cubed. Okay. Let the video know that there was someone that sneezed. LOL. All right, so here we go, guys. It says given sine x is 2/5 and the angle x is in quadrant 1, and sine y is negative 1/3 and the angle y is in quadrant 3, that's quadrant 3, find cosine x minus y. So your first move, you got to know what cosine x minus y is. If you don't know what cosine x minus y is, then we can't do anything. You know what I mean? So I'm going to go ahead and write it. I'm going to write cosine, and I'm going to write x minus y. All right, hit me.
Cosine x times sine x.
Nope.
X cosine y.
Plus or minus?
Plus.
Plus sine x.
Times sine y.
There you go. So don't worry, on your quiz on Tuesday, you'll have a little note card. But I would like for you guys to just know it, right? But you'll have your little note card and you can put that in there. All right, so I need, let's see, what do I have? I have sine x and I have sine y. So I need cosine x and cosine y. So this is in quadrant 1 because it says angle x between 0 and 90. So here's quadrant 1. Here's my reference triangle. This is angle x. And it says sine x is 2/5. So sine is opposite over hypotenuse. So if you want to write SOHCAHTOA somewhere, SOHCAHTOA. So sine is opposite over hypotenuse, 2 and 5. And I'm going to need this horizontal displacement down here, this guy right here that I'm bolding. I'm going to need that guy. So I'm just going to do Pythagorean theorem, guys. I'm just going to go ahead and do it in one step. Square root of 5 squared minus 2 squared. Are you guys okay with that? Okay. So 5 squared is 25, 2 squared is 4, 25 minus 4 is 21. So there's a square root of 21 and it's a positive, and it stays like that. Are we still okay? All right. Do you guys want me to do the other angle in a different color? Okay. So I'll do that one in blue. I don't have to. If you guys don't want me to, I won't. So I'm going to do it in blue. That's quadrant 3. So here's quadrant 3. I'm exaggerating quadrant 3. And I'm going to do a reference triangle again. Make it perpendicular to the x-axis like so. Your vertical displacement. And that says sine of y. So this is my reference angle. This is your real angle y. But we're using the reference angle to help us out. Opposite over hypotenuse, negative 1, 3. So the horizontal displacement, this guy right here that I'm bolding, is the square root, negative on the outside, 3 squared minus negative 1 squared, because it's a leg. It's one of the legs of, and you have the hypotenuse is the 3 squared. So there it is, guys. So negative square root, 3 squared is 9, 1 squared is 1, 9 minus 1 is 8. And remember, 8 breaks down 4 times 2. So this is going to be negative 2 square root of 2, because the 4 is the square root of 4 is 2. And then that 2 stays inside the radical. And everyone knows why it's negative, right? Because I'm in quadrant 3. Both x and y are negative, your coordinates. Okay. All right, I got everything I need. You guys ready? I got everything I need. So I'm going to go back to my neutral color, which is usually red. And so, okay, so time out. Some of you guys, sometimes, don't write this down because this is wrong. And I wrote it in my little notes. Some of you guys are writing like this. So cosine of x is square root of 21 over 5. Some of you guys are doing this. This is not a thing. We've never done that. So don't do that. Cool or not cool? And I'll pass back your assignment so you guys can see what I'm talking about. Cosine of x is that. So don't write square root of 21 over 5. So I guess I'm going to write this first. So I'm going to write cosine x, cosine y, plus sine x, sine y. Okay, here we go. Cosine x, I go to my angle x, square root of 21 over 5. Square root of 21 over 5. Cosine y, I go to my y, cosine, did I ever figure that out? Yeah, I did. That's negative 2 square root of 2. So negative 2 square root of 2 over 3. Are we okay with those? Plus sine x. I already gave you guys sine x. Sine x was already in the problem, but you could just look at this one. That's 2/5. Sine y, negative 1/3. Okay, let's just multiply, guys. It's just arithmetic now. Square root of 21 times negative 2 square root of 2. Double 21, so it's going to be negative 2 square root of 42. All over 5 times 3 is 15. And then positive times the negative is a negative, so minus 2 over 15. So putting it all together, guys, you're going to have negative 2 square root of 42 minus 2 all over 15. Yay! And then we look for that answer. And there it is. What do you guys think? Was that one extreme or no? Okay. All right. Here we go. We're going to do double angles. It's not tough. It's not. We're just going to do hacks. Let's start with the first hack. Of course, I can just give you the formulas, guys. And I do. But I don't want you guys to just like, oh, yeah, here's the formula. Just use it. I want you guys to see that they come from somewhere. So I'm going to write sine x plus y in the top. Do you know what sine x plus y is? Your composite argument property for this one, or your angle sum property. I start with sine. I guess you can start with cosine x also, but sine x, and then I'm going to write cosine y, and then I put a plus. Sine, cosine. I usually say cosine x. That's how I write it, and then sine y. But I guess you can say sine y, cosine x also. I just toggle. See how this says sine x, cosine y? Then I go cosine x, sine y. Because I don't have a cosine x yet. Does that make sense to you guys? Okay. And that is part of your little formulas, right? Okay. So what are we going to do? Chav, how are we going to derive sine 2a? I'm just going to derive it by calling x an a and calling y an a. And then I'm just going to expand it. See the hack? Hack. Sine a cosine a plus cosine a sine a. Sine times cosine is the same thing as cosine times sine. How many of those do you have? How many of these do you have? How many sine cosines do you have? 2. So 2 sine a cosine a. This is my double angle formula for sine 2a. See? John, why do they call it a double angle? Because you're multiplying 2 times that angle a. And those two expressions are the same. Isn't that cool? No, you guys aren't impressed. It's hard to impress. It's hard to impress. All right. You thinking about cosine 2a and how algebra is going to beat up every school in the AP calculus exam. We are gonna we're gonna beat up everyone in AP calculus, but also in AP pre-cal. Wouldn't it be cool if we had 100% qualifying? Maybe we can make it happen. I think we can. All right, cosine 2a. So again, we're gonna do a hack. We know that cosine x plus y is cosine x cosine y plus or minus? Minus sine x sine y. So instead of calling x, I'm going to call x a, and I'm going to call y a. Isn't a plus a 2a? And now look, we can just write cosine a minus sine a sine a. Do you guys like this hack? And I'll check it out, guys. Cosine 2a is nothing more than cosine squared a minus sine squared a. Side note, just in case, cosine squared a means cosine a with a square on the side, like that on the outside. And if you want to put the argument in there like that, that's what it means, guys. Yeah, we found another one. Cool, no? All right. This is you supposedly thinking, can cosine 2a be defined with different expressions? Heck yeah, I can. Oh, yeah. Heck yeah, I can. All right, guys. Hopefully you remember that cosine squared a plus sine squared a equals 1. And if you isolate, which one should I isolate first? The cosine squared? So look, here's one bullet. I can say cosine squared a equals 1 minus sine squared a. And I can replace the cosine squared a with this cosine squared a. And then check it out, guys. So I'm going to have cosine 2a equals, and I'm just going to replace it, 1 minus sine squared a minus sine squared a. That minus is this minus. And then now how many sine squares do you see there? No, not 4. 2. 1 minus 2 sine squared a. There it is. That's another formula. So is that the only one? No, this one has several. You could also have moved the cosine squared to the other side. So bullet, I can say sine squared A equals 1 minus cosine squared A. And now I can start from scratch, start from over here. So I'm going to write cosine 2A. And now I'm going to replace the sine squared. So I'll keep the cosine squared A. I'm starting here, guys, at this one. At this one right here. Minus parenthesis, and then just replace the sine squared A. 1 minus cosine squared A. And look what you get. Cosine squared A. And then distribute the minus. Minus 1 plus cosine squared A. And how many cosine squares do you see now? 2. So now here's my last formula for cosine 2A. Cosine 2A equals 2 cosine squared A minus 1. Yay. And tan, I'm not going to say that tan's not important because they're all important. But we don't usually, like this one doesn't come out as often, maybe because of the applications, but I'm sure we can come up with, reasons to use it. So let's see, tan x plus y. Do you guys have that memorized? Not everyone at the same time.
Okay, it's over 1. It's minus 10 x times 1.
Yeah, there you go. Once you've done it 3 or 4 times, you pretty much have it memorized. So you already know the hack. I'm going to turn that x into an a. I'm going to turn that y into an a. So I'm going to write tan of a plus a equals tan a plus tan a over 1 minus tan a times tan a. So then finally, what do I have? I have 2 tan a's in the top, 2 tan a, because I'm adding. But in the bottom, I'm multiplying. So tan a times tan a is? No. Tan squared a. Because it's tan that's being squared. If you say tan a squared, then you're squaring the argument. So there it is, guys. So we have another rule. So I guess I'll write it right here. Tan 2a is equal to 2 tan a over 1 minus tan squared a. And then just remember your side note that tan squared a means that we're squaring the tan. It means that. How do we feel? Yeah.
My friend who's in AC Freaka at a different school, they just started to learn about the unit circle.
Tisk.
Which basically means we're all going to qualify. Right?
Well, it means what?
We're going to qualify.
Oh, yeah. We're going to beat it up.
Yeah.
We're going to eat. We're going to cook. And then we're going to eat what we cook.
Yeah. Can we after our AP exam, I'll throw a big party?
Yeah, why not? Let's have tacos.
Yes.
Because tacos are easy to bring in, yeah? Oh, yeah, you're right. Well, maybe we'll do pizza.
I'll supply a pizza.
Yeah, all right, well, let's do this, guys. Let's continue. All right, so here are all right, guys, so check it out. So here are all the rules. Put this in your note card for Tuesday's quiz. I don't think you'll need them because I think by then time you'll have them memorized. But if it makes you feel good, the note card has to be 3x5 and put them in your little 3x5 note card. So does everyone have a calculator? So check it out. Look at example 2. Let's see what it says. If cosine x equals 0.3, find the exact value of cosine 2x. Check your answer numerically by finding the value of x, doubling it, and finding the cosine of the resulting argument. Okay, when it says check, they're literally just telling you check with calculator. So find your angle x, all that good stuff. So that means we probably should be able to do cosine 2x without a calculator. All right, guys, let's be smart. There are 3 formulas that you can use for cosine 2x. Use the one that is easiest. Chav, I don't understand what you mean. Notice they give you cosine x. So you could, if you wanted to, find what sine x is, but just use the formula that just uses cosine x. Chav, I don't understand what you mean. Cosine 2x equals 2 cosine squared x minus 1. So what is that? 2 parentheses cosine x, whatever that is, square it minus 1. Because that's what it means, right? Cosine squared. So I'm going to go ahead and start. You guys ready? They tell you that cosine x is 0.3. See how they tell you that? So I'm going to go cosine 2x equals 2 parenthesis. What is cosine x? 0.3. I'm going to square it minus 1. I think we can do this without a calculator. So let's see. 2.3 times 0.3. Chav, I need a calculator. No, you don't. 3 times 3 is 9. So 0.3 times 0.3 is 0.09. So you got to move that decimal, right? Minus 1. You guys okay so far? Okay. 2 times 0.09. Well, that's just doubling it. So that means 0.18 minus 1. And I can subtract 0.18 from 1. Chav, I don't know how to do that. Well, imagine that 8.18 like 18 and that 1 like 100. The difference between 18 and 100 is 82, but the 0.18 is smaller and the 100 is bigger, so that means this is negative 0.82. Do you guys see how we did it? Like the logic? And check it out. We didn't even touch a calculator. Isn't that cool? All right, now check it out. This is going to be so awesome. Just observe, because we already did it earlier with first period, so it might still be in here, but I'll clear it just in case. Where's my calculator? So now they're telling me to double the angle x, and you're going to see it. It's going to be awesome. It's going to be awesome. Yeah, we did it earlier, so I'm going to pretend that's not in there. You didn't see that? 7. Oh, let's clear the memory. Second memory, 7, 1, 2. All right, check it out. So they told us cosine x is 0.3. Let's go to degrees, because I think you guys are easier with degrees. Like, you'll understand it better, I think. It doesn't matter. You can leave it in radian. You'll get the same answer. Check it out. So cosine of what degree gives me 0.3? Obviously, it's plus or minus, but let's just worry about the positive angle. Check it out. Second arc cosine of 0.3. So this angle. So if I double this angle, I better get negative 0.82 when I do cosine of that. So here's what I'm going to do. I'm going to store this, and I'm going to store it to A. Are we still cool, guys? Look, cosine to alpha A. Do you think that's going to give me that negative 0.82? Isn't that cool? Oh, you guys aren't impressed? I think this is so cool, guys. Like, look at that. Like, okay, I'll stop. No, you're good. You're good. Is it cool? Okay, it's cool. Yay! I wish I had pyrotechnics. Okay. All right. How's my quiz gonna look? It's a quiz on Tuesday for you guys. It's gonna look like this. See how we did the first one here? You're gonna have one of those. And we're going to have, obviously we're doing double angles now, so you're probably going to have a double angle. Something like this. Relax. It's not that bad. It really isn't. Look, cosine 2x. I guess on this one I tell you that it's in quadrant 4, but you really don't even need it. Cosecant x is negative 6. So the reciprocal of cosecant is sine. So that means that sine x is a negative 1/6. These. I guess, I guess with half angles we should be careful. That's why they have the plus minus. On these, you don't have to worry. All you got to do is pick a formula that just uses sine. So I come over here, or just memorize it, guys. It's not hard to memorize. And I'm like, oh, look at that one right there. So I can just go cosine 2x is equal to 1 minus 2 sine squared x. Remember what that means? It means this, 1 minus 2 sine x, and whatever that is, square it. And OMG, they gave me sine x. Not directly, but they gave it to me. 1 minus 2, open parenthesis, sine x is negative 1/6, close it, put a square on it. See? Parentheses, 1 minus 2, negative times a negative is a positive, so 1 times 1 is 1, and 6 times 6 is 36. Now, I like to reduce it here, but I've noticed that some of you are getting like a little confused, so I'll just go ahead and write it like this, and then reduce it. This 2 over 36 reduces to what? Perfect. 1 over 18. Chav, I need a calculator for this. Guys, no, you don't. You can probably do it in your head mentally. This 1, you can rewrite that as 18 over 18, can you not? Yeah, and then 18 minus 1? There it is. See? You guys can do it. Si se puede. That was Spanish. I don't know. All right. Write an equation expressing cosine 10x in terms of sine 5x. All right, guys. So what they're telling you, I just want you to observe that is twice 5x, and this is like your original angle. That's just 5x. So that's like saying this guy is 2a and this guy's a. That's like saying that. And so which formula am I going to use? Well, cosine 2x equals 1 minus 2 sine squared of x. That's the formula I'm going to use. So I'm going to write cosine of 10x, remember that's 2 times 5x, equals 1 minus 2 sine squared of 5x. That's it. That's all they wanted. I know, it's not too, you're kind of like, whatever. It's not too like, wow. Okay, last one. Write the equation in example 4 directly from the composite argument property of cosine. Remember, sometimes they call composite argument properties angle sum difference properties. Okay, so what are we going to do? So let's see. We're going to say cosine 5x plus 5x, because 5x plus 5x is 10x. And I'm just going to use the composite argument property for cosine. Equals cosine 5x minus sine 5x sine 5x. And from here, supposedly I want to get from here, and I want to get to that formula there. We're still okay? Okay. So let's see. Cosine 10x equals cosine times cosine. As long as the argument's the same, that's going to be squared. And then sine times sine, as long as the argument's the same, that's going to be sine squared of 5x. And if you want to put parentheses on the argument, you can. Textbooks, and myself included, sometimes have bad habits. And we don't put parentheses, but we should. But some textbooks don't even bother. Are we still okay? You get to here and you're like, child, we're nowhere close to that. Well, remember Pythagorean theorem or the cosine squared plus sine squared equals 1. So side note, cosine squared 5x plus sine squared 5x, as long as the arguments are the same, both of those, when you add them, will always equal 1. Always, always, always. I know, guys, we're almost done. Move the sine squared to the, let's see, what am I trying to prove? Yeah, I want to get that. So move the sine squared to the right so we can get cosine squared by itself. Cosine squared 5x equals 1 minus sine squared 5x. That's what I'm going to substitute. So here we go. And I'm slow down. Cosine 10x equals, and I'm going to substitute 1 minus sine squared 5x minus sine squared 5x. Last move. Cosine 10x equals, how many of these sine squares do you see? 1 minus 2 sine squared 5x. Done. What do you guys think? Are you not entertained? Yeah, I'm entertained. Are you not entertained? Yeah. Hopefully this video helped you out. If it helped you out, give it a thumbs up. And yeah, guys. So I think now we know enough to take care of that activity. You should be able to finish it all because the morning class was able to finish it all. So yeah, and then let me know if you guys have any issues.